So that's going to bring us to cardioids that look like hearts. Okay, so what you're going to be asked to do on the test is, if you're given an equation, I'm going to have a table that you need to fill out, and then you're going to graph it to the best of your ability. Right? So yes, you can use your calculator, right? So, but I'm going to do it really by hand here. Actually, let's go ahead and bring up that calculator. All right, so I'm going to clear that. I'm going to clear that. I have 3 plus 3 cosine theta, and I want to go to my table. Well, notice it's not cranking it out. Let's do table set, which is right there. Now that second window. So I want it to start at 0, and it looks like, I don't know, I could count maybe every 15 degrees. And then I want it to say auto. That will automatically populate all these things every 15 degrees. Or you can leave it as ask and type in the numbers you want. That might be a good thing. So let's just say ask. Okay, so if I go to table, okay, I want 0, I want 30, because remember I am in degree mode, 45, 60, 90, 180. Now most of these values you should be able to do without a calculator, but some of them I gave you were kind of ooky decimals. All right, so let's see if I calculate this. This is 6. This is, say, 5.6, 5.1. And then if I wanted to see the graph, going, it is a sideways cardioid. Right, so what do I want my paper to look like? Well, so here's 0, 1, 2, 3, 4, 5, 6. I'm going to plot that point. Here's 30 degrees. 1, 2, 3, 4, 5. Let's see. 1, 2, 3, 4, 5, and a little bit more. So that must be 6 way out there. And then at 45 degrees, a little bit closer to 5. At 60 degrees, a little bit less than 5. And then finally at 90, we're at 3. At 180, we're at 0. So what's the calculator doing? It's coming around, coming around. Remember, making that heart shape. At 270, it's going out to 3. And it's going to do the same thing around there. So again, looking at the calculator, looking at your paper. Zoom 0 is going to round it up a bit, like as in not round up as estimating, but it's going to make the figure look rounder. And again, you can see that it is 6 wide and 3 up and 3 down, and that corresponds to those numbers. Okay, so that's what I'm expecting on the test. Okay, so let's look at this one. Let's see if I don't have to use a calculator. Right, so it's good practice. So r equals 2 minus 2 times the sine of 0. Well, the sine of 0 is 0, so that would be 2. The sine of 90 is 1, so that's going to be 2 minus 2, which is 0. The sine of 180 is 0, so that's 2. Now the sine of 270 degrees is negative 1, so that's going to be 2 plus 2, which is 4. Alright, so 1, 2, back to 0, 2, 1, 2, 3, 4. Now again, you could look at that on the calculator, but it is going to be a heart-shaped figure, symmetric with respect to the y-axis. You could verify that on your calculator. Now, I kind of zoomed over this part. What makes it a cardioid? Those numbers are the same. All right, so 3 and 3, 2 and 2. The cosine one is going to be symmetric with respect to the x-axis. The sine is going to be the y-axis. The plus sign is going to be on the positive axis. The minus is going to be on the negative axis. Next thing we're going to look at are limacons with a loop. So these numbers no longer are going to be equal. The first number is going to be smaller than the second number, but all that symmetry is still going to come in to play. Right, so I'm going to pop open my calculator. I'm going to clear that. I'm going to type in 2 minus 4 cosine theta, and I'm going to do second graph and create my table. So I have 0, and those were the thetas are from the last exercise, so you can keep them. They're about the same. So I want to get down here to 60, then 90, 180, 270, and then I'd need to punch in 300. And at 300, I get 0 again. So it's supposed to have a loop. So let's go ahead and look at the graph. And you see I can't see much because on my last one I did zoom 0. So let's just go back to zoom 6. Alright, and so as expected, it's symmetric with respect to the x-axis. It's on the negative part of the x-axis. Alright, so let's just plot those points and see if we can duplicate this. Remember, at 0 degrees, instead of going towards 0, we're going to go backwards, so that's 0, -2. This is 60 degrees. We're going to be back at 0. At 90, up at 2. 180, let's see, 180 at 6. 1, 2, 3, 4, 5, 6. Because this is 180 degrees. All right, so what have I done? Let's see. So from -2, we did this, and that's how that makes that loop. And it's going to come around and do that. And then at 270, we're going to get back to 2. And then we're going to go back through the loop, back through the pole at 300 degrees. So let's look at the relationship between here. You notice that distance is 2. 2 minus 4. This distance is 1, 2, 3, 4, 5, 6. 2 plus 4 is 6, so that's that long part, all right? And then we went up 2 and down 2. So again, you can use your graphing calculator, but just look and see what's happening. Also, I want you to notice I gave you some specific numbers. Those are the two angles that the graph went through. You could call it the origin, but that's really not correct. It's through the pole. Now let's look at the math, because we're going to have to do that on the next example. Basically it says, when does r equal to 0? So you're solving this equation. If you let r equal to 0, how could I solve for cosine theta? Well, I'm going to subtract 2. I'm going to divide by -4 and get 1/2. So where all does the cosine equal to positive 1/2? Well, it's in the first and fourth quadrant, and those are the two angles. So that's and so really you're doing theta is the inverse cosine of 1/2, and theta is 30 degrees and 300 degrees, and that's where it went through the pole. Okay, so let's look at that next example. All right, so let's do this without the calculator. What's the sine of 0? 0, so that's going to be 1. The sine of 90 is 1, so that's going to be 5, 1 plus 4. The sine of 180 is 0 again. The sine of 270 is -1, so this time I have 1, 4 minus 1, so that's 1 minus 4 is a -3. And then we're back to 360, which goes back to there. Okay, so at 0 degrees, we're at 1. At 90, 1, 2, 3, 4, we're up to 5. 180, 1, 270. Oops, not, see, that's wrong. I plotted 270 positive 3. Here's 270. Negative would be in the opposite direction, because remember, we're going to create a loop. So really what has happened here is we went from 1 to 5 back to 1, But somewhere along the line, how did I get to that? Well, I had to pass through the pole, make a big loop, pass through the pole again. You can check that out on your calculator. So what I want to know is, when did it pass through the pole? What is theta? So we're going to do this algebra. We're going to say when r is 0, because that's when it passes through the pole. So subtract 1, divide by 4. Now this is not something we memorized from trig. We're going to need a calculator. Okay. So again, I want to make sure I'm in degree mode because that's what I want my answers in. Okay, so I want theta to be the inverse sine of -1/4. Now before I punch that into my calculator, I want you to think. What two quadrants is the sign negative? Quadrant 3 and quadrant 4. So I need two answers. So inverse sine of -1 divided by 4. I get -14 degrees. Well, that is in quadrant 4. We're going to call it 0.5. Or I could add 360 to it and call that 345.5 degrees. But how do I get quadrant 3? Well, I think about reference angles. Okay, so if this is -14.5 degrees. My reference angle over here is also 14.5 degrees. But I need to go from 0 all the way around. So I need to add 180 to my 14.5. And I get 194.5 degrees. So where is that approximately? Well, 345. Let's see, this is 360. So -15 is somewhere about right here. Went to through the pole there, and then with symmetry it's going to be really the same thing. Right there. Now the reason why I'm making you do this is because you're going to have to do it in your calculus classes. So to answer this question, the graph passes through the pole when theta is 194.5 degrees approximately and 345.5 degrees. Next type are limacons without a loop. They're not as pretty or fun, but they look pretty much the same as the ones with a loop. It's just that this one is now bigger than that, and that's what makes it not a loop. It's kind of flat on one side. So again, you could use your calculator, but these are pretty easy values. So 6 plus 4, the cosine of 0 is 1. This is going to be 6 plus 4, the cosine of 90 is 0. 6 plus 4, the cosine of 180 is -1. And you can kind of see a pattern here, and that's going to be 0. So, we have at 0 degrees 10. 1, 2, 3, 4, 5, 6, 7, 8. Way out here. At 90, we have here at 180. So it just kind of flattens here. I'm not doing a very good job, but it's good enough. Okay, that's really all I expect on a test. It does not go through the pole, does not have a loop. So let's just look at that on the calculator, since my graph was not very pretty. 6 plus 4 cosine theta. Again, I'm going to do zoom 0 to get that fit. So you can kind of see it slightly dimples. That one's so much better than mine, but that's really as good as I can get it. But again, I want to go back to that symmetry. We have cosine, we have a plus sign, symmetric with that horizontal axis, and the most of the graph is on the positive part of what we would call that x-axis. Right? So on this one, I would anticipate symmetry with the y-axis and most of it being on the lower part. Right, so we would have 5 minus 4. The sine of 0 is 0. The sine of 90 is 1. And the sine of 270 is negative 1. So here we have 9. Mine looks almost like an acorn, doesn't it? You could leave it on zoom 6. Just this, the zoom 0 just makes it a little bit bigger. All right, and you can definitely see that that 5 plays an important part. It's out 5, over 5. That's up 1 because you had to subtract, and here you had to add and get the 9. But our symmetry, it's symmetric with respect to the y-axis, again because of that, and here. So limacons without a loop.